Welcome to our channel. Today, we are diving into the concepts of quality assurance and quality control. Understanding the difference between these two can help you improve processes and deliver high-quality products. Let's start with quality assurance. QA is a proactive process that focuses on improving and fine-tuning the methods and processes used to create a product to prevent defects from occurring in the first place. It is primarily about ensuring that the processes followed during product development and manufacturing are effective, and that standards are being adhered to. Now, let's talk about quality control. QC is a reactive process that takes place after the product has been developed or during production. It focuses on identifying and fixing defects that occur during or after the production phase. While QA is process-oriented, QC is more product-oriented, and aims to ensure that the final output meets the required quality specifications. QA looks at the processes used to develop products. Its main aim is to refine and optimize these processes. QC focuses on checking the product itself to ensure it meets specific quality requirements. It checks for flaws, defects, or nonconformities. The key philosophy of QA is prevention. By ensuring that processes are followed correctly, it helps reduce the likelihood of defects or errors in the product. QC works by inspecting, testing, and measuring the final product, detecting any defects, and taking corrective action. The proactive approach in QA focuses on preventing defects before they occur by establishing and improving processes. The reactive approach in QC focuses on identifying and addressing defects after they have occurred, ensuring that only quality products reach customers. QA involves creating and maintaining documentation, policies, and guidelines to ensure consistency and high quality in production. It often includes standard operating procedures, process checklists, process audits, and training for the team. QC often involves testing products against predefined standards, specifications, or performance metrics to ensure they meet quality benchmarks. Let's talk about QA tools and techniques: standards development, audits, process documentation, training, continuous improvement. These are the QA tools and techniques. Standards development, defining internal and external standards, such as ISO 9001, that govern how products should be developed or manufactured. Audits, regular audits of processes and workflows to ensure compliance with established standards. Process documentation, creating detailed manuals and guidelines that outline the development and production process to avoid errors. Training, ensuring employees are well trained in processes, standards, and best practices. Continuous improvement, implementing frameworks like Six Sigma or Total Quality Management to make ongoing improvements to processes. Now let's talk about QC tools and techniques: inspection, statistical process control, sampling. Testing, non-destructive testing. These are the QC tools and techniques. Inspection, checking products for visible defects or performing dimensional verification using tools like calipers, micrometers, or gauges. Statistical process control, using statistical methods to monitor production processes and identify trends that might indicate defects. Sampling, inspecting random samples from a production batch to determine whether the overall batch meets quality requirements. Testing, conducting stress tests, performance tests, and destructive testing to evaluate product durability, safety, and reliability. Non-destructive testing, techniques like X-rays, ultrasound, and magnetic particle testing to check internal or hidden defects in the material. Now let's see the example. In software development, QA might involve defining a set of best coding practices, conducting code reviews, and ensuring the development team follows those practices. In manufacturing, QA might ensure the use of reliable machinery, well-defined workflows, and supplier management to reduce variability and ensure uniformity. In a food production facility, QC would involve inspecting the final packaged goods to ensure they meet safety and quality standards, perhaps checking for the correct weight, packaging integrity, or expiration dates. In the automotive industry, QC would involve testing the mechanical components of a vehicle to ensure they function as expected. End goal of QA is to build quality into the product from the start, avoiding issues in the first place, and making sure that the process that produces the product is under control. While the main goal of QC is to ensure that the final product meets customer expectations and specifications by identifying and eliminating any defects. Now let's see the main differences in QA and QC in brief. QA focuses on improving the process to prevent defects, while QC focuses on inspecting the product to identify defects. QA is a proactive approach. It focuses on preventing issues before they occur, while QC is a reactive approach. It focuses on detecting and correcting issues after they occur. QA is a process-oriented, while QC is a product-oriented. The main objective of QA is to improve processes and ensure quality in the development phase, while the main objective of QC is to check and verify product quality before delivery. QA activities like audits, process documentation, training, process checklists. QC activities like inspections, testing, defect identification, and correction. In QA it happens during the design and development stages. In QC it happens during the manufacturing or after production phase. Six Sigma, ISO standards, audits, SOP, TQM, these are the QA tools. Inspections, SPC, NDT, destructive testing, these are the QC tools. How QA and QC work together. In an ideal scenario, QA and QC are complementary. QA ensures that the processes used to manufacture or develop products are optimal and prevent defects from arising. However, despite these processes, defects may still occur. This is where QC steps in to identify and correct those defects before the product reaches the customer. For example, in a manufacturing plant, QA might involve ensuring that machines are calibrated correctly and workers are trained according to proper procedures. QC would then involve inspecting the final products or parts to ensure that they meet the required dimensions, material properties, and other quality standards. Why both QA and QC are important. First, reducing costs. Preventing defects through QA reduces the need for costly rework, scrap, or customer returns. Second, improving customer satisfaction. QC ensures that only high-quality products reach the customer, reducing the likelihood of complaints and maintaining the company's reputation. Third, continuous improvement. The feedback from QC can be used to further improve the processes monitored by QA, creating a loop of continuous quality improvement. Both QA and QC are integral to achieving a high-quality product, and most industries use a combination of both to maintain consistency and excellence in their output. Remember, quality is not just an act, it's a habit. By integrating both QA and QC, you can achieve excellence in your products. We'd love to hear your experiences with QA and QC in the comments below. If you found this video informative, please like and subscribe for more insights on quality management. Thank you for watching.